Okay, so let's talk about solving trig equations, right? And specifically for angles that are between 0 and 360, right? And that's actually 0, 360, right? It's a whole circle. Kind of nice. All right, so a little review. Here we have a right triangle. As long as I locate the actual angle, opposite that angle is the opposite side, adjacent is adjacent, and always opposite of the 90 degrees is the hypotenuse. Right? And so again, since it's a right triangle, I have the trig ratios, right? Sines opposite over hypotenuse, cosine of the angles adjacent over hypotenuse, and tans opposite over adjacent. And so realize, right, the ratios themselves are actually, or the trigs, right, the trig ratios are ratios of sides. That's why they're called trig ratios, right? So if I actually had values for the sides, then sine is opposite over hypotenuse, so it's whatever this value A is divided by the value C. So whatever that number is that I get, that's actually a ratio of sides of a right triangle, okay? And that goes for all three. Okay, so let's use that and figure out, I want to do two things. I want to, first of all, well, I really want to do this is to deconstruct the meaning of this, all right? And then solve it. So the first one is, I want to do a right triangle and really understand what this means. Okay, so I have cosine theta, right, equals a number. Well, we realize that cosine means trig ratio, and trig ratio for cosine is adjacent over hypotenuse. So just looking at this, we can say the adjacent side is 1 and the hypotenuse is 2. Okay, the other part that you have to make the connection with, as soon as you see a trig ratio, right, it has to have come from a right triangle. These really just explain right triangle ratios, right? That's their definition. So once I have a right triangle, I can locate theta. I'm just going to put it in the bottom left. You don't have to. You can put it up top, but that's where I'm going to put it. And now once I locate that, I know adjacent is below, opposite's opposite, and hypotenuse is, well, hypotenuse is always opposite 90 degrees, right? So now that I've located this and drawn a triangle, I can actually label my adjacent and hypotenuse sides. So since cosine is 1/2, adjacent will be 1 and hypotenuse will be 2. So just seeing cosine theta equals 1/2 gives you this entire triangle, right? Well, it gives you, when I say entire, right, I still don't know the other values of the opposite side or the angles, right? But it gives me this triangle, this right triangle, all right? Okay, so that's what I need you to start seeing. Don't just see this as gibberish, as just cosine theta equals 1/2. See this as a right triangle with adjacent 1 and hypotenuse of 2, okay? All right, so now let's solve it. Here I want to get access to this theta. Cosine is in the way. Cosine is a function, so I can't divide by cosine. What I need to do is inverse, all right? So I'll do the inverse of both sides. And inverse for a trig function, we put a -1 at the top, just like inverse for functions, right? After the -1 was an inverse. And so now we did inverse work before. An inverse of itself, right? By definition, they undo each other. So the inverse cosine of cosine, those will undo each other, and you'll be left with just theta, right? That's how we get access to functions, right? Variables in functions, inverses. And then inverse cosine of 1/2, that'll be, well, calculated for us, but we could also do our special right triangles, right? So this will just be 60 degrees, all right? So now I figured out that this angle is actually 60 degrees. So just by seeing this, I can get the total big right triangle. And then by doing a little inverse, I can actually get this angle. So now with all of these, and I'm not asking you to do this, now I know this is 30 degrees and I could get this other side. I can solve this entire triangle, all right? Okay. All right, so let's stop this, and you want to do classic problem 1. Okay, so let's do this. I have cosine of 60 is 1/2, right? We just showed that from the other example, and it generates this particular right triangle, right? Well, if you type in your calculator, you'll notice that cosine of 300 is also 1/2. So what does that mean? Does that mean that this angle now should be 300? Well, no, right? It's not possible. Because a right triangle, any triangle, the angles add up to 180 degrees. So this is ridiculous, right? So which means I can only figure out trig ratios with right triangles, but now I have an angle such that I can't make a right triangle. Something's goofy, all right? So what we need is a workaround. And this, in my opinion, is quite genius, is what they came up with. So the first thing is I can make a right triangle with 60 degrees. So let's do it. And then I need angles between 0 and 360. So let's get a coordinate system that does that. So let's just pop up our, our general Cartesian coordinate where these two axes are perpendicular. And then we'll make the positive x-axis 0 degrees. And then you'll see once I go all the way around, it'll also be 360, right? And then we'll make the positive y-axis 90 degrees because it's perpendicular. Then we'll add another 90, and we'll make the negative x-axis 180 degrees. And then we'll do another 90 and make the negative y 270. And then you'll see, if I add another 90, I'll go back to 360. So now I have a way to do a right triangle, and I have it in a system where I can actually map out up to 360 degrees. So the question now becomes, is there any way, so cosine, right, I need it to be an adjacent side of +1 and a hypotenuse of +2. Well, is there anywhere in this coordinate system I can draw this right triangle such that the horizontal side is +1 and the hypotenuse is 2? Absolutely. I could draw it right down there. Right? And just make a note that each hypotenuse will always be positive. It's only the x's and the y's that'll change sign. So now look, I've actually done right triangle trig, and I put it in a quadrant that is between 270 and 360. So let's go from 0, right? And if I go to 0 to this first hypotenuse, well, that's my first answer is 60 degrees. Well, if I go from 0 to the second hypotenuse, then that's going to be my answer of what? Well, the whole circle is 360, but I don't want this 60. So I want the entire thing less 60. So 360 less this 60 is 300. And that's how we get the second solution. That's how putting it in this coordinate system, we have, 0, 90, 180, 270. That's how I use right triangle trig to find ratios of angles that I could never possibly make a right triangle for, okay? And they call these reference angles. This is just a reference triangle because clearly 300 can't make a triangle. Well, this is a reference triangle that gets me that relationship, okay? All right. So if you'll just type in your calculator, you'll notice cosine of 60 is 1/2, right? Which we knew, so adjacent over hypotenuse is 1/2, and then cosine of 30 is also 1/2, so adjacent over hypotenuse. All right, okay. All right, so you want to stop this and complete crossword problem number 2. All right, we're going to start solving a bunch of these, and there's a nice relationship between the quadrants and which trig functions are positive or negative. All right, so that's what we're going to go over now. And we call these, little sign charts. So notice this, here's just a general right triangle in the first quadrant, which I can always make because it's 0 to 90. I can always make a right triangle here. Opposite side is y, adjacent side is x, and now this is the unit circle idea. We're going to make this hypotenuse 1. Right? It'll just make the calculations easier. So sine is opposite, which is y over 1, and then c divided by 1, sine is y, which means that sine is just the y value of any triangle I put in these 4 quadrants. Right? So to do our sine chart, notice in the first quadrant, y is positive. So sine will always be positive for angles in the first quadrant, 0 to 90. All right? Well, y is also positive if I copy this triangle to the second quadrant, right? So that means that y will be positive for all angles 90 to 180. So any angle 0 to 180, sine will be positive. Well, let's flip it around. If I put this triangle and I flip it over the x-axis, now this y value is in the negative y direction. This is a negative y. So it means that in the fourth quadrant, sine is negative because y's are negative. And then in the third quadrant, sine is negative because y is negative. So we just found out that sine will be positive 0 to 180. So if you take sine of any number 0 to 180, it'll be positive. And then 180 to 360 in there, if you take that sine, it'll be negative. Well, let's see. So here are my 4 things. Sine of 30 first quadrant, positive 1/2. Sine of 150 second quadrant, positive 1/2. Sine of 210, that's third quadrant, negative 1/2. Sine of 330 fourth quadrant, negative 1/2. Okay, and the take home here is sine is y. So if you want to fill out this sign chart, ask yourself when y is positive and when y is negative. All right, we can use that exact same logic on the rest, on cosine and tan. Cosine is adjacent, so x divided by 1, again, unit circle. And we did that, so now we know cosine is x. So now if we think of cosine as x, this sign chart is just going to be when x is negative and positive. So the first quadrant x's are positive, so it's a positive in the first quadrant. copy this down to the fourth quadrant because it shares a common x, right? This x will also be positive, so cosines will be positive in the fourth quadrant. And then third quadrant, I have a negative x, right, for the adjacent side. So third quadrants are negative. Fourth quadrant, negative x for the adjacent side. So third quadrants are negative. So 0 to 90 and 270 to 360, cosine will be positive. 90 to 270, cosine will be negative. So let's try it. Well, cosine of 60 is in the first quadrant, that's positive. Cosine of 120 is in the second quadrant, that's negative, like we said. Cosine of 240, that's in the third quadrant, that's also negative. And then cosine of 300 in the fourth quadrant, positive. All right? Okay, let's do our last one. Let's do tan. So tan is opposite over adjacent. Opposite in our general triangle is y, adjacent is x, and the hypotenuse, right, doesn't even matter here. So tan is y over x. So now to do my sign chart, I need to figure out when I divide y and x, whether it's positive or negative. So positive y divided by positive x, tan is going to be positive in the first quadrant. Well, flip it over, diagonal. A negative y divided by a negative x, the negatives will divide out, and it'll be left with a positive. All right, so first and third quadrant, tans are positive. So between 0 and 90 and 180 and 270, tan will be positive. Well, let's try here. If I do the second quadrant, y is positive and x is negative, so I'll get a positive divided by a negative. That'll be a negative. And then in the fourth quadrant, I'll get a negative divided by a positive, so negative y divided by positive x is also negative. So 90 to 180 for tan is negative, and then 270, 360 is negative. Well, let's try them. So tan of 45, first quadrant, positive. Tan of 135, second quadrant, negative. Tan of 225, third quadrant, positive. And then tan of 315, fourth quadrant, negative. All right? So those are our sign charts. All right, so now go to your classwork and just complete your sign charts. And make a little note, I would at least, right? When you do your sign chart for y, or a sign chart for sine, you're just looking at y values. When you do your sign chart for cosine, you're just looking at x values. And when you do your sign chart for tan, look at y divided by x. And again, you're just looking for sines. Okay, now let's use all of this to actually solve cosine from 0 to 360. And now every trig function, when you solve it, will have two answers, two angles that produce the exact same ratio, right? Side ratio, right? Except on the axes. So the axes are different. So let's do this. I want cosine of 75. All right, so since it's cosine and since it's a positive number, I know I'm going to have triangles in the first, or I could possibly make triangles in the first quadrant and the fourth quadrant. Well, let's inverse both sides. So I'll get inverse cosine of 0.75 is 41.41 degrees. Well, from my sign chart, I know that that right triangle can be made in the first quadrant. And remember, it's trig, so we're always looking at right triangles. All right, so now I need another right triangle. I didn't show the right triangle, but it is right here. All right, I need another right triangle where cosine will be positive, and that's where this sign chart comes in. So I'm going to copy this triangle to the other place cosine is positive. All right, and so now my first angle is from here to here, which is 41.41. My second angle is from 0 degrees all the way to the second hypotenuse, which again, the whole thing is 360. I want to less this 41.41. So my second angle will be 318.59. All right, so that's how we'll use these sign charts to know where to put my second triangle, second right triangle. Okay, that's actually it. So you can stop the video and just complete the classwork.